that's considered a dissection from a circle, or part of a circle, and that is a sector. Okay, a sector is defined as the figure enclosed by two radii. And the arc cut off by them. Right, and again, the arc cut off by them has a name in this particular case because it is cut off by the angle, that central angle, so it's an intercepted arc. And so it's just, again, an enclosed figure formed by two radii, and then the portion of the circle that's contained between those two radii, and the intercepted arc of that. So as far as the naming conventions go, once again, it's just going to be named sector, and then it'll be labeled by the endpoints of its arc. So sector BC. And you might also see that it's named as the sector cut off by a given central angle. And so it might say a sector cut off by a central angle of 32 degrees. And so now it's referring to this central angle, which again coincides directly with the arc measure. The only special property that we're going to be dealing with involving a sector, as far as this section is concerned, is its perimeter. And once again, if you just kind of build the perimeter is the sum of these two radii, so 2r, plus this arc length, the portion of the circle from B to C, okay, so lowercase s. And once again, we can accomplish this in two different ways, either in terms of radius or in terms of a diameter. So since we're given our first part in terms of a radius, if I take the arc length, which is m over 360, times c, well, c in terms of a radius is 2 pi r. So I get my equation in terms of radius. Now, if you want, you could reduce this even further. You could cancel the 2 and the 360 and reduce that as well, but there's really, again, no specific need to do that. And the other case would be if I wanted to express this instead of 2 pi r, if I wanted to express it in terms of a diameter. The circumference in terms of diameter is d pi, and so I can also express 2r in terms of diameter. Twice the radius is how many diameters? Just one, right? It's a direct relationship. So you could also express the perimeter for a sector as being d plus m over 360 times d pi. This is arc length. And so again, anytime I use a lowercase s, and I'll designate that with a little, like the little loop at the bottom, that's the arc length.